In part 4 in this series on percentage compositions, I tried to explain in detail the logic behind the algorithm used to determine the molecular formula given the percentage composition and molecular weight of the compound. But in this video, I am just going to walk through the steps without much explanation. Here we have a toxic acid composed of carbon, hydrogen and oxygen, and here is the percentage of carbon and hydrogen, and here is its molecular weight. We have to find out its molecular formula. See, here this compound is made up of 3 elements, but we are given the percentages of only 2 elements. So you have to first calculate the percentage of the third element. How do you do that? Simple. The sum of the percentages of all the elements in the compound must add up to 100. That's by definition. So to get the percentage of oxygen, you have to subtract the percentage of carbon and hydrogen from 100. So here is the percentage of oxygen. Now once you have the percentages of each element, you know the drill. In 100 grams of the substance, there is this much of carbon, this much of hydrogen and this much of oxygen. That is what we mean by percentage composition. And we also know the molar masses of their atoms. And if you divide the given mass with the molar mass of their atoms, you will get the amount of substance or the number of moles. So upon simplification here, you would get 2.225, 2.2 here and 4.44 here. Pay attention to the units. So there are 2.225 moles of carbon and 2.2 moles of hydrogen and 4.44 moles of oxygen in 100 grams of the substance. And to get the simplest ratio, you have to divide these with the smallest of them, and that is 2.2 moles. And when you divide 2.225 with 2.2, you would get approximately 1. This is within the experimental error, so you can ignore these 2 digits. 2.2 mole over 2.2 mole is 1, and 4.44 mole over 2.2 mole is again approximately 2. This is within the experimental error. So the simplest ratio of carbon, hydrogen and oxygen atoms in one molecule of that compound is 112. So the empirical formula of this compound is CHO2. Then how do you get the molecular formula? First you have to calculate the empirical formula weight by adding up the atomic weights of all the atoms present in that molecule. And you know how to do that. And for this empirical formula, the empirical formula weight comes to 45. And the experimentally measured molecular weight of this compound is given, that is 90. To get the integer with which the empirical formula must be multiplied to get the molecular formula, you have to divide the given molecular weight with the empirical formula weight. So it becomes 90 over 45, so it is 2. So you have to multiply each subscript in the empirical formula with 2 to get its molecular formula. So the molecular formula of this compound is C2H2O4.